Welcome to part 2 of the roundtable on investing in tools. In this part, we get into the topic of paradigm shifts, and in particular, we focus on visual programming and non-textual programming paradigms. We discuss things like the viability of visual scripting for general purpose programming. Several examples of non-textual programming, such as blueprints, Houdini, and Excel, are discussed to some degree. We talk about issues like the tight coupling of tools that comes with a lot of visual programming systems and the need for language designers to also be UI designers in a visual programming system. We talk about possibilities for making visual programming more effective, such as automatic layout and alternative ways of representing information in a visual way. We also discuss the perils associated with exploring an infinite design space such as this one. And of course, we talk about a lot more along the way. I hope that you find this conversation interesting. I'd love to shift in two ways. One, to thinking about the sort of big meta wins of building new tools. So what happens if we build a whole new programming language, or what happens if we replace the tool chain with something that's got a much better like this or that and has better code gen on this side because it uses this technique and user-facing errors and guiding helper tips and all that kind of stuff. Like, you can imagine forever what you would do with a tool. We can also start mixing in what kind of tools would change the game, like visual scripting and other non-textual style things like there's the entire future of coding community that like iterates on the different non-textual things. Obviously Ryan and I did the Dion demo a few years back, and then there's other things like not quite non-textual, but they sort of Brett Victor's inventing on principle, the like live feedback environment kind of ideas. So there's like this whole realm of blue skies things, and even more grounded, but just like new language semantics or new tool systems, better IDEs, better debuggers, and how that would make life better. And is it like, how do we decide to take on a project like that? So instead of the conversation we were doing before, which is I have whatever project I want and I'm sort of making my tooling decisions locally, your project is going to be the tool you're going to build. So this kind of shifts the discussion, because now we're going to have to think about like even more clearly, how do you know if spending 5 years on this tool idea is going to pay off for anyone? Whereas before we were time boxing it, that's not going to, like, you can't time box the whole project in a certain sense, right? So to get that part of the conversation kicked off, what I think would be interesting to do is let's loop in these more like esoteric things like non-textual programming and just get a read for how does everyone feel about like the idea of a total paradigm shift being something that's going to come online in the future. And if that is going to come online, do you think it's really going to make a big difference, or are most of the problems we have now going to be the same then? Like, what do you guys think about that kind of approach to making software quality better?
I think in the same way that Einsteinian physics had to sort of encapsulate and explain Newtonian physics, the next paradigm shift in programming, which I think is like, I think it's inevitable. I think everyone knows that there's something inadequate about current computing tooling, and I think everyone's trying, like, well, not everyone, but a lot of people are working on like their ideas for solutions. And I think that whatever picture comes up that does cause a paradigm shift, that will necessarily have to account for all the truths of like the ecosystem we're in today. And I forgot the exact phrasing of the original question, but I think it's like, is that on the table? Like, will that happen necessarily? I think like, I think probably. I don't think that the decisions made in like, the beginning of computing up to like the 1970s maybe are going to dictate things for the rest of time in computing. But I think like whatever new story comes after this will necessarily have to account for that as well. So I think, I don't think it can just be like, everyone throw your computers out the window, here's this new device, it's totally brand new kind of thing. As much as maybe I would like that, I think that's just not the way reality ever works. Like, people invest time and money into big projects built on the current ecosystem. It has to sort of be more gradual than that. I don't think there's another alternative. But I think people are, especially with the rapid change in hardware, I think software tooling has a long way to catch up. And so I think paradigm shifts are totally on the table.
Okay, but what about visual scripting?
I think textual programming is just a special case of visual scripting. Like, people separate these concepts in their heads, but text is a file format that has a binary representation that is visualized on screen, and people manipulate that binary data with a visual editor for it's a very simple format, but I don't see any reason why that has to be the only format for the rest of time. I would say that when it comes to, depends on what you want to draw, depends on where you want to draw the circle called visual scripting, but I think it's very clear that that'll happen.
When you say that'll happen, I want to just clarify, are we talking, because obviously blueprints in Unreal exist and are successful
Right.
in the sense that games are shift on that technology now. I do think there's a debate to be had about whether they're successful in the sense that they actually made the development cycles better in the majority of cases. Some people who have worked with them say no, but others have a case as look, I don't think my designer, artist people would have touched it, and so we kind of got some more programmers for free in a sense by having it, and other people are no, the programmers end up having to do all the work. And it's there's all these different sub conversations there we could explore and see what everyone here thinks about it. I'm very curious what John thinks about it, because since he's the one who's brought that one particular, and also what your visual scripting idea is. So there's a separate question, which is, does it replace the root node of the ecosystem,
Right.
where you could write operating systems and web servers, and the whole thing could be bootstrapped up from this new paradigm, rather than it being a sort of sub tool within the paradigm we have, right? So that's what you're saying when you say it'll happen.
Right.
I think that's the key question. It's I think there are visual scripting languages, and none of them are general in a way. They're all subcomponents, harnessed within standard software. And there do exist visual ones that are general, but none of them are used in a general, widespread manner. I think the closest, which is still, is it general? Okay, I'll throw out this example now. Maybe better do it later. But so there's a tool called Houdini, which is powering 99% of the VFX industry. Literally every film that uses VFX uses Houdini, and it powers physics simulations and animation and basically everything that goes into the pipeline. And it's fundamentally a visual scripting tool. I would not call it scripting, but the root node is visual stuff. The nodes are implemented in Python sometimes and other languages, C++ and stuff. So is it the root node is maybe up for question, but that's the closest thing that I think there exists. There doesn't exist something to me though that's Java or C++. I think there should be, but I don't think there is. I will take the point of view that I think there could be. I think that you could make a visual, and I don't like the word scripting. I think you can make a visual language that's better than textual languages. I think that's definitely true, but I don't think it exists yet.
Yeah.
I don't think it'll ever exist. Sorry. I see them as basically domain specific languages that are good because of the places that they happen to have been used. That's not happened, but they're used in very simple cases where you don't have to fit much on the screen or much in your head at once. And I think they are brilliantly deployed in Unreal Engine. The Unreal Blueprint system is pretty cool because it means that someone can use this kind of programming light environment to do their stuff. But I don't think it's ever going to replace code. I think what will eventually replace code is some sort of neural link, like the Matrix, that. I think that has much more promise.
Yeah.
But just because of all the lines that are going everywhere, how the rectangles have to be spaced out, and how they...
I think those are limitations of the lack of creativity on the part of visual scripting designers at the moment. I think when people make visual scripting languages, they're let's make it an imperative scripting system where execution is passed between nodes as if it were lines in a program. And of course it's going to be terrible because you're taking all these things that were meant to be read line by line and then spreading it out into spaghetti, and it's just a mess. But I think that the area I'm interested in with visual languages is more of a declarative style. So part of the reason that some functional languages work well is because they can be very terse, but they're kind of a pain in the butt to write, to actually write and develop in. But I think if you made... And actually, Houdini is a declarative language, which is partially why I really think that's worth looking at. So something that, rather than defining, okay, step by step, here's how it works, you define a set of nodes and structures that say, okay, here's how I want it to look at the end, and it sort of figures it out for you. It's a different way of programming for sure, but I'm not sure that it is beyond possibility. I just feel like there hasn't been that much creativity in the space.
Yeah, so I agree, and this is why I started my point by saying text is a version, like the people have this false dichotomy of textual language programming or visual language programming, and a lot of people assume that visual language programming is exclusively this like data flow node graph kind of thing, which is what people have done, and as you guys have said, like works very well in these domain specific cases, like shader graph scripting for artists at like within a game engine, or audio synthesis program, like very simple scripting style programming for like effects applied to sound as it moves through a pipeline and is eventually like fully processed and output or something like that. But I think that's and this is a much more generic view of or generalized view of visual programming, I guess, which is that like I really do think it's a false dichotomy. I don't think that it's text or data flow. I think that at the very core of the problem, the first principles of it is that humans express data in some format that like eventually causes computation. Right now, we do that with a sequence of UTF-8 code points or something, and that gets sent to a compiler that parses it and produces a structured representation and like generates code eventually. I don't think that the UTF-8 code point list is the end-all be-all, and I don't know if it's necessarily the best either, and I think there's a lot of potential, in my opinion, I mean, this is now just getting in my opinion, but there's many potential wins, I would say, in changing that format a little bit, and this gets into the Dion stuff, obviously, but that's mainly what I wanted to say. It's like, it's not data flow or text, these are both examples of visualizations of a data format that is somehow visualized to the user that somehow encode computation. And so there's a lot of room to play with that. So I agree with what you said, John. It's like there's a lot of possibilities that I think people have not really explored.
Okay, so I want to, since you're not all on the same side here, instead of asking a challenging question to all three of you at once, what I'm going to do is sharpen up the differences here and see if we can figure out where the root cause of the difference of opinion is, and also make sure that this is a difference of opinion and not a difference of definition and all that stuff. So first of all, Evan, is that the things that Ryan and John, which they appear to be agreeing on, is it making sense to you what they're saying, or are there aspects of what they're saying that you need clarification on?
I think I need a little clarification on what Ryan was saying. I understand what John was saying.
I mean, I can try to reinterpret what Ryan was saying.
Yeah, that'd be cool.
And my understanding is just that it's sort of the abstract statement that text is just one way of encoding our thoughts. Like, it's a good way of encoding the way a program should work. But you can imagine incremental differences from text to different formats, or like text with like one superpower XYZ that like, lets us do something that you wouldn't normally think text could do. Like just, you can imagine incrementally tweaking text to just be a little bit better or something like that. Or even tweaking language, like the English language, or the concept of language as a whole, like that you could maybe get at a better way to represent things. Like in a lot of ways, we are trying to compress this idea of algorithms into an English format. And like, that's because we work in that language day to day, but like maybe there is a better way of thinking about it. And like in a lot of ways, like we often do that anyway at an abstract level when you make like a build system, which is a directed graph, or you make like some sort of IR that has some interesting SSA formulation or something like that. Like those are different ways of encoding an algorithm or a program that are harder for us to interact with, but might be a better formulation if we could just find a way to work with them directly. If that
that does make sense.
Yeah, and I can provide maybe a little bit more insight that's like maybe a little bit less abstract. And this is something like we spoke about in the original Dion stuff, but the idea of like error containment is a very like recognizable problem for all programmers, because everyone has at some point or another forgotten a curly brace, and the problem with like the curly brace, like a missing curly brace in a file, is that it's like undetectable if you want to stay true to the rules about like white space in the language or something like that. In a language like C. I mean, maybe some languages have significant white space or whatever, including with curly braces, but I mean, like, humor me for a minute. Imagine you're all programming in C and you miss a curly brace somewhere. It's an undetectable problem for the compiler, like which one you forgot to close, basically, because it has this whole thing where it's like you have a file blob, and that's all you have. And you're just scanning like left to right inside of this file blob, and you find an open brace, and you're like, oh, okay, I'm just parsing code, and then it's like, oh, end of file, like what happened? Like I didn't find the closing brace I needed. You don't know which one it went to. So I mean, a very simple improvement over text, and maybe this is like also possibly about file systems. Like this is like something you could think about, but a very simple incremental improvement would be like maybe instead of one file containing one blob of text, maybe it just contains several buckets of text. And so if we find an error within one of those buckets, and so this would be a much finer granularity, for example, than like right now people will put like, 100 functions in one file or something like that, because it's just more ergonomic to do that. Like file systems are not built for the kind of code navigation that you really want. That maybe would have done this with file systems, basically like bucket text in more convenient sort of spots. So people don't really follow the rules of putting one function in a file because it's like unnecessarily non-ergonomic. And of course that like destroys your day-to-day life programming. But I mean, if you had a more rapid way to navigate around all these like named code blobs in a way that they weren't, in the way that they were like precisely bucketed, where no one concept could span between two of them, unlike, just loose text in one file, then when it comes to like a missing curly brace, now you've scoped down the error to like one much smaller portion. But you've also fundamentally changed the data format. Now you don't have a text file anymore. You have like a list of text blob file or something like that. So you've changed the fundamental format in some way. Now it's not visual scripting, but I also don't think it has to stop there, right? But that's just one example of like bucketing text is one tiny little incremental improvement you can make to text that does cause this error containment to just be like, everything's well scoped at that point.
All right, so thank you. I'm gonna take it back to Evan's. Are you following that? And also, is it make sense why they're emphasizing this?
Yeah, absolutely. I think my main contention, which isn't something you guys actually said, so I might be arguing against the straw man here, was that we should almost start from something like Unreal Blueprint, like start from the rectangle-based like visual scripting language, and I just see like a lot of parts of that as a step backwards in the specific context of general purpose programming. Like for Unreal, that worked great because of many other factors. What Ryan was clarifying, and John helped clarify too, was that if we kind of blur the lines between text, like code, and the more visual aspects, then I do see some promise there. And we already kind of see it. Code folding, those little minus and plus things on the left side, those are totally an example. And you can even do that in like intra-line, like in the middle of a line. You can just collapse that away if you don't want to worry about it. If you hold control and hover over a thing, like it'll become kind of like a hyperlink and you can then click on it. So it's like, I guess we have kind of been departing from strictly code for a while. And I admit what you said, Ryan, kind of I never thought about it, about dividing a file into multiple sections. And like the thing is like the Veil compiler kind of does that in a way, but not as elegantly as I think you're presenting it. The Veil compiler actually uses the leading white space as a hint for compiler errors. Like if you eventually come across a func, like func keyword that is right after a new line, then the lexer and the parser will know that, okay, this is conceptually you're starting over for the error state. And any errors like end here, just nuke everything above it if there's anything suspicious, and just keep compiling from here from a sane state. But I've never thought about what it would be like to kind of do that at a level higher than text. Yeah, so now you've nerd sniped me, and I'm thinking about it.
Well, I'll save you from that and move on a little bit, and also we're going to keep building up. So there's kind of these two. We're kind of looking at this as like two different endpoints on a spectrum, like vaguely right now, which is like text. This little step up from text, and then there's blueprints, and then I think the example of Houdini is like blueprints, but with like actual text behind it. So it's like a step back from.
Let me describe Houdini a little bit better, because Houdini is the reason I'm so pro visual languages is what I would call it, but and this shifted when I used Houdini, which is funny. Like I used to be, Evan, in your exact same point of view, because I never used a good visual language. They were all just terrible. But then I used Houdini, and it is the first time I've ever felt like I was in a true flow state when I was programming. And like sometimes it's happened before when you're like, you know exactly what you want to program and you just like kind of knock it out. But it kind of requires you to kind of have already written that code before in a lot of ways for your fingers to actually like basically in Houdini, if you're good at it, the limitation is how fast you can input the nodes. Like it's like when you're in the flow of like making a program in Houdini, it's just like it's beautiful. It's hard to describe. It's like it's an emotional moment. And like I think that was like, and it's still super powerful. Like it's super flexible and it's really interesting. It's still sort of not quite general in the way that you
yeah. So well,
but that's sorry. Sorry, and I said I was going to describe it too. So the way it works loosely is it's basically a language that kind of okay. Let's see. It hovers somewhere between declarative, like sort of functional declarations of what things should look like, and more like pipelines. I think it's better to describe it as like a pipeline steps. So like you might define like, oh, create a cube, and now take this cube and rotate it 40 degrees, and now subdivide that cube, and then pass that cube into a fluid solver and have that run 8 steps. Now take the output of that and pass that into a voxelization engine, and now take the output of that and run marching cubes on it, or whatever. It's just like you're just going down, and you can sort of like, and it also gives you like other axes, so you can like simulate things over time and things like that. But when you're really in the flow of just like kind of dropping nodes down, you can just drop them down super fast. It's all keyboard based, and like it's impressive what you can do so quickly. And so what it triggered in me was like, oh man, like this is really limited. It's very scoped for VFX, but like it made me realize that there was maybe a if we just sort of tweaked it a little bit, we could make this a bit more general. But at least it made it feel like there was a possibility, at least.
So, yeah, I think that helps a lot. So it's not quite the same as blueprints, it sounds like. It's like structured a little bit more.
Fundamentally, there's no execution. So like the difference between this and the visual scripting is that in blueprints, you have one thing that runs after another, and you have like a kind of a thick line at the top that always says like, okay, what's the next node to execute? There's no state in Houdini. It's all pure. So like if you drop a couple of nodes down and you've got your cube that's just run through the fluid simulation, so you take out that goop, whatever comes out of that, I guess. You can like use that node, and that's a immutable piece of data. It's locked that way, and so you can draw that node and drag it to something else. Maybe you throw it through the voxelization engine, but maybe you also like pass it through a rendering. You render it from a certain camera and take out like a silhouette of it or something. And then now when you go back up to the top, you can just change the initial inputs, and the whole thing just recalculates like a build system. And so you're building this incremental program that is where every piece of data is immutable, and it's a transformation, it's not about imperative execution.
Gotcha.
It's hard. I'm doing a terrible job explaining this.
No, I think I from what I understood, you're saying it's more like an Excel spreadsheet in my understanding of Excel, where it's like each cell in Excel can have a formula that can refer to other formulas, but you can't. There's no time in any of that. You can get like plugins and extensions that do these like simulations over time in Excel, but mostly the way you set it up is just like this cell calculates this, and then you can go change the numbers in your table and it'll change the calculation, but there is no control flow in any of that. So it's very functional.
Yeah, exactly.
And
I think it's exactly correct to say it's like Excel, except they also give you a time axis, which you could imagine as being like a 3D grid of like Excel, nodes or spreadsheets probably. But the other thing that it's doing particularly well is, and this is a deep topic, but one of the things it does particularly well is it gives you very high level nodes. So like rather than, one of these problems that visual scripting has is they always choose their nodes to be way low granularity. It'll be like add 5 is like a node or something, or it's like core mathematical options are nodes. No, it's like the node is like physics solve. Like that's like the node, and it does, and that node has like 30 bajillion settings on it, which sounds like a nightmare, but is amazing because once you know how to use it, you drop that node down, you click all the settings you want, and then like boom, you've got this like crazy physics simulation that you just drop down. And that balance of power is really interesting. Like it allows you to quickly sketch out a lot of stuff.
I wanted to mention one thing on that. I think that hooks into something I was thinking about earlier, and I think I said this, but the idea that some paradigm shift would have to sort of like become the new substrate on top of which the old paradigm still makes sense and operates to some degree. And I think like my prediction is like you could imagine a future programming environment that does have these more visual elements in the same way Houdini does. And the high-level nodes thing makes a lot of sense because within one individual high-level node, you could imagine just someone implementing one of those nodes in C or something, right? Like it's just
and in fact they are.
Yeah,
I think
exactly. So I think that model can make a lot of sense. The specifics of how that happens at like systems programming level instead of Houdini level is like unclear.
Right.
But I think that it's like a promising direction to me, at least.
Yeah. So I think the like primary challenge that I think can be mounted to the like optimism for visual scripting from my perspective, based on what I've heard, like based on the case you guys have made so far, comes down to answering this question, which is Houdini is this, special case thing. Blueprints are the special case thing. The point is to say, like, look, there's not really any particular reason why this doesn't seem like it could go general, but is there a win when it does go general, or do we still carry over all the same problems? Like, what is there to be gained from taking the fully general root node of the ecosystem and turning it into one of these things? And I think a way to sort of look at that same question, but from the other way around, is could Houdini have been just a scripting language and been just as good by having each high-level node replaced with a high-level just like function call thing? So it could just look like a functional language.
So one of the benefits of using a visual system is that you gain a very natural way to debug. So with a function, with a normal textual scripting language, one of the problems. Let me clarify. I have been working on a general Houdini language for several years. It's a hobby project, so you can get me talking about this very, very intensely. So one of the things that so like if you go to debug a textual language and you're like, okay, I know at this line this value is wrong, but I want to know why. Oftentimes you can't just look up sometimes you can just, look up the text and then you find out why it went wrong. But oftentimes it's over function boundaries, or it's in the middle of a loop, or it's something like that. And suddenly you need like a really advanced debugger to sort of trace backwards and figure out why something happened. So one of the key parts of a Houdini-like language is that it is, it's basically not Turing complete. Like it's a directed acyclic graph, and that's all it ever is. There's no recursion, for instance. You can't you can sort of wrap functions and into sub functions and stuff. But at the end of the day, it flattens all out to some sort of almost build system like graph. And so whenever you hit an error, it's like that node turns red. You can just work your way back up. You can essentially binary search your way up the node tree until you figure out that's where the value is wrong. And I think that's a value you can't get out of a textual language if that textual language has things like recursion and function calls and arbitrary nesting and things like that.
So I think that really sums up the difference. Okay. So I would be curious about whether those benefits come from the visual nature of that language or from these other choices that they've made. Like you said, it's declarative, and that's a huge win. Like when code can be expressed in a declarative fashion, like it is debuggable, it's readable, it's easy. We often hear a lot of the same things about functional languages unless they are tower of abstractions like Haskell. And it sounds like you're dealing with a really well-designed API, I guess, like these high-level nodes, the proper abstractions that fit what you're trying to do really well. It also sounds like the scope of the problem is, like, for example, I'm not hearing like any suggestion that we would use a visual scripting language to make something like Spanner, right? Like millions of lines of code to manage a database, right?
Yeah.
And then you also said something interesting, which was that it's got some really slick UI. Like you said something that almost sounded like an autocomplete, and then you can really get into a
Yeah.
flow state. I think that there are programming languages out there that do all that. Prolog comes to mind. It's a declarative language. It's great at higher abstraction things. It has to be because it's declarative. And I would imagine there's some IDEs for Prolog with autocomplete, but I don't know. So I guess my root question, and I could be totally wrong on this because I haven't used Houdini, and so I can't say for sure. Do these, like, is Houdini better because it's a visual scripting language, or because it was developed by people who made a really solid tool and had and fit it to the domain really nicely?
I think you're really cracking into the right point, because I think I agree that, like, it's not so much that it's a visual language. Part of it, I think, is that the visual language forced them to design it in a certain way to make it a little bit more declarative. I think at its core, what I've come to believe the crux of the satisfaction and what works is that there's actually two languages happening here. One is this sort of purely declarative build system node-based language that sits on top, and then each node, which is implemented, in straight C++ or Python or whatever the node's implemented in, which may be thousands and thousands of lines. And I think we often want to think of a programming language as like a singular tool that we use to build the entire stack. But I think they've gotten a lot of value out of actually splitting it and like having this non-Turing complete language at the top, and that sort of, but can always like break down into normal C++ within a node in order to do the actual things you need to do. I think that's kind of, and that top level non-Turing complete like sort of declarative language could be text. Honestly, I don't know if it has to be visuals. I think it's nice that it's visuals, but I don't know if it has to be.
Yeah, I think I would also ask the question, why did the Houdini developers choose something visual versus doing this thing as a textual language? And I think it has to do with what decisions you make at the beginning. Like if we were to like imagine ourselves as designing the computing ecosystem at the beginning of history, and which we aren't, but if we imagine we're in those people's shoes, what decisions we make will determine the sort of landscape of what is easy and what is hard. And I think when we're thinking about building ecosystems for the future or building tooling environments for the future or something, I think it's important to think about the idea of what you're making easy or what you're making hard. And so this gets into the visual programming stuff, because I think when it comes to textual languages, my experience has been writing tools for text is maybe a lot harder than I expected it would have been. And I think that, like you can learn it, but ultimately it feels as though a really solid editor, for example, or a really solid, you could get in like debuggers or visualizers or anything like that for a textual language. It always feels like every tool you would like to write for text turns into this incredibly complicated knot. And there's ways of factoring it, like, I don't know, import Clang, and then you can parse the C++ source easily or whatever. And it's like, yeah, but like, what does that do to the quality of the tool? How many Clangs are there out there? Like, can I switch to Clang if they're too slow and I need an alternative competitor? Like, is that possible? And that's also a function of how easy it was to build Clang in the first place. And so I think like the decisions you make at the beginning of the ecosystem do have an impact on what's easy and what's hard. And I think what's easy and what's hard also determines basically the number of people who will try to implement certain things and the number of competitors you get as a result. So, one question you might ask is like, hey, why is there only like a few debuggers on Windows? And it's like, oh, maybe it's because writing a debugger is like very complicated. Like, not many people write debuggers. Like, it seems like a huge rabbit hole, and everyone has these amazing ideas about like, like we just saw the, I don't know if you guys saw it, but it was the Tomorrow Corporation, like all their internal tooling, and it's all awesome stuff. And then it's like, like, why is that not anything people have tried to implement for like C or C++ programming? And it's like, oh yeah, because it's like massively complicated when you try to do it there. And it's like almost nobody's going to do it. And so you get almost no competitors, and it's almost impossible for people to iterate substantially in that domain. And so when it comes to the visual tooling and stuff, it's like maybe the choice of the visual presentation and format had to do with how easy it was for them to produce all of this stuff later. I don't know for sure in Houdini's case, but I think it's like an important variable that factors into all of these topics.
Yeah, that really fits in with a comment I was going to make in response to what John had to say. So, and even the questions Evan was raising, which is that it sounds to me like, first of all, the sort of functional declarative structure of Houdini was a part of what made it work, and that secondly, the fact that it has some really great like interactive debugging tools that are not flow breaking. It's not a separate program or like a separate mode. Even Visual Studio's debugging experience, if you use their editor, is not like very good at not breaking your flow. It is a huge thing, and it sounds like you're in Houdini probably like you type in some parameters, a node turns red, and you go and look at it. It's like a integrated experience. And so part of the question, of course, then is like, well, why not just do that in text? And I think what Ryan is saying is like, well, maybe there's good reasons why not do that in text, and that the win for the visual scripting language kind of shows up there and not on the language design side as much as you might think. Does that sort of sum up what the two of you would?
Yeah, that seemed like a pretty good summary.
I would still quibble with that a little bit.
Yeah, go for it.
I think you're not wrong. Like what you said sounds right, and I think I would agree with it. But I would say that those aren't necessarily because of an inherent weakness in text. I think that's an inherent weakness in C and C++. Like, I would know firsthand, like when you're designing a language and you're not shackled by backwards compatibility of especially C and C++, you can do some really incredible things. Like the deterministic replaying. Like that's one thing that C and C++ would really struggle with. Like RR came close. That's a time traveling debugger. But I haven't yet really heard any benefit of visual scripting languages that can't be fit to a similarly new text-based language. Except for one thing. I might be wrong on this one specific part. John, you mentioned that when you're debugging, it really easily shows you like what nodes are red. Can you tell me more about that? Because I don't know if text can do that. Like in the way you're talking.
So, for example, and it's helpful to sort of imagine maybe like a bit of the structure of it. So you might have you have a directed graph of nodes, right, that you're seeing on the screen, and then some of those nodes are also subgraphs, which are, if you could dive into them, and are nodes themselves, and are essentially just a way of like zipping up a bunch of nodes to make it easier. It'd be like using a region folding or something like that. That's kind of like the nature of it. So if let's say you have a program that's got 100 nodes in it or whatever it is, and then you tweak some inputs at the top, maybe you give it a new input file or something like that. And what you'd see is like the output node at the bottom turns red. And then basically, because it's hit an error or whatever it is, and then every node above it, basically until where the original error started, kind of turns red as well. This is, and let me be clear, I am pitching also partially the language, the pure ideal language that Houdini is. There are a lot of practical problems with Houdini, so just be clear that I'm pitching the ideal version in my head of what it should be. But so like every node up the tree would turn red until like the source of the error, basically, because you can basically imagine it like a result in Rust or something like that, or an option type. So like basically all the values that pass through the transform after you hit an error just also spit out errors as well and sort of bundle it up. Does that sort of make sense?
Yeah.
So you'd see a bunch of red nodes going up the directed graph kind of until you hit that original.
So I'm trying to think
error.
if a language like Prolog, a text-based declarative language, could do something like that.
I would say that Prolog's a little bit different because it's declarative in a different way. That's more like a query-based system, where this is closer to. It's hard to describe. It's more like a build system, and I haven't seen a lot of text languages that are more like that.
So just to I think I understand how you've described Houdini, but I want to double check now to make sure I'm following. But I'm pretty sure, if given the analogy to Excel, it would be equivalent to like a functional language, where by functional we mean there's no side effects to function calls. But you also don't write functions in Houdini, it sounds like. You just call pre-existing functions, and you pass parameters in, which can be, literals, or they can be variables. But variables can only be assigned once, and then they're like available down.
That's a good way of putting it. If you represent Houdini in text, it would look like SSA form, that's a compiler sort of representation. I'm sure you know what this is, but just for everyone on the podcast, it's a compiler representation where every value is only ever defined once, basically. And so you get this kind of everything is immutable sort of sense to it. That's kind of what it would look like, I think, if you wrote it in text, which would maybe work. I don't know.
Right. So you could imagine a language that was like they have to come in order so that the debugger can then visualize the path of redness through these identifier chains or something. Like you could, and I think that's what Ryan's getting at. It's like you could imagine building it up in such a way that the debugger gets back there, but isn't the node graph so much easier to color red than the text that the debugger is looking at, or like something like that.
I'll give another example of what sometimes it can be useful to have the nodes over text language. One would be like when you want to sometimes like split executions. Like maybe you calculate a bunch of data or whatever, you've got to do some queries or make some math happen. And you've got some like, intermediate data that you like. And now you want to take it in two different directions. In Houdini, this would be like, well, maybe I want to see what this simulation looks like if everything's on fire versus if everything's smoky or something. I don't know. You just split the tree and now you can suddenly be doing things in parallel. They both depend on that initial data, but you can hop over to this half, you can hop over to that half. In the extent of that, that becomes spaghetti and becomes messy. But in just doing just a little bit of that can be very useful, because in text you'd have to like split it by jumping way down in the file maybe or something. And it might not be quite as easy to tell that this value is up here is actually used by like 1, 2, 3. In like Houdini, you like look at a value and you're like, how many times is it used? Just count the wires coming out of it. Okay, it's used 5 times. Okay, and then you could follow each of them. Again, in the extreme of that becomes very messy. So I'm not necessarily making an argument for that structuring, but it's interesting, I think.
So I do have a different direction I'd like to go into, the sort of flip sides here. I've been bolstering up the visual scripting side for a few rounds, but I do think I have a concern with the direct making non-textual stuff work that is a little different from the kinds of issues Evan has raised. So I'm going to come at this from another angle and see what y'all think about this. So a separate issue here is that when you have an idea for a programming language or an idea for any other kind of development tool in the current paradigm, you can go and implement that and give it to other people to use, and they can use the rest of the tools they're familiar with. Like, they don't have to learn a new editor with a new set of key bindings. They don't have to be worried that like this proprietary format that they're writing all of their code in might suddenly become something they need to parse, and they have no idea what's actually in the file. And of course, there's like, if I don't like Visual Studio, I can go get a different debugger. There's like Remedy out now, and I can go on Linux and get a debugger or two. Whereas if I'm using your visual scripting system, I'm using your debugger, and however good it is, and I can't write one of my own if I need to. And version control is another huge aspect to this, like blueprints, which might be a great fit for some Unreal users, also always come with this like version control nightmare because they don't plug into the existing environment. And so I think there's a separate concern here that to me is more like how do you justify making a system of non-textual tools when they have a lot of these benefits? They tend, like in the Houdini case and in a few other cases I've seen, they tend to get those benefits by being tightly integrated, by having all of these things being a closed loop. And I'm not convinced myself that that is the right basis for like the root of the graph, right? Like if we wanted to write an operating system in something someday, how would you write an operating system in a proprietary node graph or whatever specialized format? If you kind of want the ability to plug and play and move more nimbly at the bottom layer of the system like that. And so I don't know what's a resolution to that concern, if anything.
I've thought about this a lot in making my own visual scripting language, because pragmatically, if it can't handle or be represented in text somehow, it can't integrate with other things. I think my one quick aside is that I think we like to think of C++ or C as non-proprietary, but like I don't think it's any different than another binary format, kind of like what Ryan was getting at. Like text is just one sort of encoding that we just happen to sort of glom onto as a standard. But you could imagine some sort of binary format that is for visual scripting and like has the same level of standards compliance as C, and like everyone agrees, and has all the tooling in our perfect world that, you could just pick through it and you can totally write an OS in it. Now, I want to dispense with that, but the actual pragmatics of it, I think, is the simple answer is just that we shouldn't be saving visual scripting as binary files. We should just save them as text. And specifically, I think the way to do it is kind of what like Evan was saying, which is when you go to save a visual script, the text representation of that visual script should look like a programming language. It should just like you should be able to read it, and so that when you look at a diff, it's like, oh yeah, like look, they changed line 56, and it's like when you bring it to the tool, it's like okay, now it's visual, but like at least when in the diffing and source control, all of that would just look like a normal textual language. It might be a weird textual language. It might have some issues on readability that would be otherwise if it was handcrafted, But I think that's a good in between. Maybe there's actually a tool that already does this called Luna, I think, which is a visual scripting language. Kind of inspired. It looks a little inspired by Houdini. It's like got some transforms and kind of pipelines of transformations, and you can seamlessly swap between visual scripting and a functional Haskell like language. It's like it's encoded at the same time in both, which is really weird. It's you can go play around with it. I think it's in like an open alpha or beta or something, but I think that to me feels like a good path forward, at least for the time being.
For me, this question comes all down to, I suppose, it depends on what your perspective is exactly, but if you're thinking from the perspective of someone who is like, I guess the first thing I should say is that if you imagine that the base format, like the root node, is not text, then what's definitely true is someone had to go and invent the format and build the tools and like do all this stuff. Like there's a ton of work to do. And then you can given that aspect, if you imagine someone who's looking at this like new parallel ecosystem and they're like, oh, like we can't use Git. We can't use this stuff in Git. We can't use our diff tools. We can't use our editors. We can't use our debuggers. Like all of it's not going to work anymore. I think it comes down to basically any other sort of business decision, which is just it's also risk versus reward. It's like, what are you giving up and what are you getting in return? And I think that what exactly shape that takes depends a lot on what the ecosystem looks like. So if it's totally closed and proprietary and there's no way anyone could ever implement another editor, or there's no way anyone could ever implement like anything else, like there's only one group of people on the planet who know how to parse the format at all, like that's probably concerning, right? And I think that makes it much higher risk and possibly much lower reward. I mean, that probably makes it a lot worse actually, because then you can't write your own custom tools and stuff. And so whether or not it's worth, if you imagine, okay, full proprietary is out. So there's got to be some like open standard and there's a bunch of people who have gotten together and built tools for this new ecosystem or something. Then you have to lose all your tools still, but then maybe it's still worth it. But the only way it would be worth it is if there's actually all these benefits provided by this ecosystem. And if that's true, then maybe the reward is high enough that some people would start to adopt it in some more pragmatic way. Now, I don't know. You can't predict what one person is going to think, let alone 500 million people or a billion people are going to think about that kind of a decision. And it really depends on like things that no one person would ever be able to predict. But I do think that you can change the game a lot. If one example just being like all the base stuff is open, even if there are new tools, they don't dispense with all of the standard like control schemes or something. Like there's a lot of things you could play with there. I think, and the reason why I think that'd be preferable is that I think to some degree, if you're going to like do this huge revolutionary change to the computing ecosystem, you kind of have to like wonder if you're ever going to be hamstringing the wins you could have had by attaching yourself too much to text. And I think that the impulse to stick with text is like reasonable because there is all this inertia behind it and there is all this tooling behind it. But I think my personal feeling is that the benefits probably outweigh the costs of a new format. And there was another angle I wanted to get on that too, which is like goes back to the discipline stuff we were talking about and the other like non-tooling stuff we could talk about, like how easy is this thing to learn for new people? Like, do we want people to be learning how to program in text for the rest of eternity? Or like maybe this is way easier to teach to like young kids or something like that.
I think you have to very much separate in your head when you're trying to design something like this. Do I want this to be some sort of like North Star of purity, like Haskell or something? Or are we doing something pragmatic like Rust? I think where like they're just like, well, we'll tweak a couple things, but then we'll just be really pragmatic about everything else. And like, I don't know. I think there's value to both.
I remembered one thing I was trying to get to in my spiel. When talking about like what is possible inside of text versus what is possible inside of like a new format, and it's very clear that there's a huge overlap between those two categories. The thing I would want to like raise, and this is like a comment, not necessarily like a direct question or point or anything, but the thing I'd want to raise is that I think it's worth being careful about what we assume our null hypotheses to be. Meaning, like, what do we assume is sort of, where do we place the burden of proof on people? You know what I mean? Like, is it enough to say that all of the same things are possible in text? Or is the burden of proof really on the text format people to be like, no, prove to me why text is worth sticking with? Is it actually going to make all the things that we would like to be easy, and, you know, what other things does it make hard, and have you done a full accounting of all that? And I think, like, for me, I don't think that it's obvious what the null hypothesis is, because we're in the land of, like, conjecture and probability and everything. But I think I would just put that out there as, like, I think it's worth being very careful about what we assume the null hypothesis to be when evaluating the validity of one argument or another.
Yeah, I think in response to that point, I think there's, or maybe I'm reiterating that point more strongly, but this sort of connects into all the stuff that we talked about earlier about evaluating tools in the small, where it's like, how do you know if Go versus Rust is doing a better job at preventing this class of bugs, except instead of in a very narrow case where it's like, this is the class of bugs and these are the two tools and we're comparing it. And we were like, yeah, you can kind of figure it out, but it's kind of a gut feeling even when you collect data. Now we're talking about taking total accounting of all possible pros and cons for rewriting every tool in the entire ecosystem, right? So there's all the costs involved in rewriting each tool and all the pros that you can only evaluate if you've finished implementing the whole thing. And even then, we don't think you can evaluate it super well. So it leads to this really hard problem of like, is there a fair way to ask someone to justify a claim for or against an entire ecosystem rewrite? Or is there just no, like, I'm not sure I don't know if I have any way that I could say this is a fair bar that you have to meet to convince me, but I also don't know if I have any way to say like there's good reasons to think this besides my gut feelings on a lot of these things.
I think you're in the realm. I think you're in the realm of like research projects that take a lifetime, and you hope your children will benefit. Kind of. I don't know.
I think maybe for the last question or second to last question, to sharpen up what we were talking about a minute ago, I was asking you guys to think about the issues that come out of the change in ecosystem to one that's sort of this closed loop. And there are these cool benefits you get out of the closed loop, but I'm concerned that the best benefits that you see in something like Houdini might be coupled to the closed loopness of it. And that as you get closer and closer to something that is generalized, you might also get back to having all the same problems you had before in text. And it might be that you've shifted the balance, as Ryan has, I think, pointed out. I don't necessarily have a reason to think that won't be the case, that you might have shifted the balance where visualizing things in a debugger gets easier, but maybe the editor is now a much bigger difficulty. I think a very sharp way to put this is, in this future, do language designers also have to be graphic designers? Like, do you have to know how laying things out graphically and building UIs works to do a language now? Or is there, like, is that something that ought to be coupled? And or you know, on the other side, is a language a thing that makes sense? Like, what, there's some amount of expressing computation in a structure has to happen. And in the text mode, we just say, hey, you think about how to relate ideas into an expression of computation, and someone else is going to lay them out on a screen and save them and serialize them and deserialize them. Like, a bunch of other stuff is going to happen, and you don't have to be an expert at the UI side of things. But in Houdini, I imagine that someone had to play both roles. And is every new language always going to be both? Or is there, like, some way to untie that knot so they can be nicely decoupled like they are in the text land solution to computing?
So one of the more interesting revelations along those exact lines that I've had is that a lot of the languages we use today are actually multiple languages put together. For example, C++ is, even if you ignore its macro language, its templating language is different than the rest of it, right? The declarative language at the very top level, where you're saying, like, this is a class, this is a struct, this is a function, that is a different language than the language that happens inside the function body, the actual expression imperative language. So there, like, even if you try to make a language that is the same all up and down the stack, like it can be done. Zig is a pretty good example of this, but you do miss some opportunities, and those opportunities can be shown by things like Unreal's blueprint, right? It's like if you have a level at which it is much easier to operate at a very high level, simplified, if you can sit on top of a very nice abstraction that models the problem really well, then that is so much nicer to work within that. I guess you called it a walled garden. It's so nice to work within that instead of having to worry about malloc and free everywhere. Like it's so much better. And so I think that any solution we can come up with, well, I should say, I think the best solutions we can come up with will be ones that have that divide in a wise place. Like you can do low level things if you want. There's escape hatches for that, such as in Unreal you can break out into C++. In Rust you can use unsafe to break out of the borrow checker. It sounds like in Houdini you can break out into, I forget if it was C or C++.
Yeah, you can just write them.
Yeah, and I think the languages of the future, the well designed ones, will have that kind of divide.
Yeah, I definitely agree with that. I feel like that's one of the reasons I like Rust in a lot of ways, and I think it's managed to get actual adoption is because you can break out of it. C Sharp has actually been developing a similar thing. Like a lot of the latest Unity tools are all written in an unsafe flavor of C Sharp that uses pointers and directly manipulates the garbage collector in various ways. And I think that's allows you to do a lot more powerful things rather than trying to fight back some sort of arbitrary system. Like having written a lot of Java in ages ago, like where before they had that kind of stuff, it's just like, man, it's a very different thing. I think to your point, Alan, about the do language designers need to become UI designers? I think I would argue that they already are UI designers. Like text is just a form of UI. The benefit of writing a text-based language is that you have like 50 years of like history to work off of. Like you can, if you only make a couple of tweaks, you can make it a lot like C, and most of your work is done for you. It's not going to be terrible. You can still really mess it up, but most of the time your syntax is going to be fine if you stick to something C-like. The difference with visual programming is that now you have nothing to go on. Like there is some history, but I would argue it's all bad in totally different ways, and we haven't quite figured it out yet. We haven't cracked the nut. So you're going to be flailing around a lot. But theoretically, if visual programming did take off, then like somebody could make a sort of core library for laying out nodes and rendering them in nice ways that just all of the visual class of languages used in the same way that we all use text as a basis. Like you could imagine something that knows nothing about programming. It's just a sort of schema for laying out and encoding nodes and like using that as maybe your core format and then compiling it in different ways.
Yeah, I would also so I agree with that, and I would also say, to some degree, if you have a system that operates independently of design, you cannot expect that it will produce anything of good design. So I think this partly ties into like the idea of like you get what you measure, and things will be formed by the reality that they're contacting with, or that they're in contact with, basically. So I agree that like the reason why text languages are maybe like seen as like having these principles of design is because they have this history that everyone sort of works off of, and probably unknowingly, because people learn languages this way and they're like, well, this is the only way I can really think of a programming language, so here's how it's going to look inside of a text file or whatever. And yeah, I agree that like the same thing would happen in a visual programming environment. And I think that's actually a good thing. Like in some sense it's adding more responsibility to the language designer, and certainly that's like, you could argue that's a drawback, but I also don't know if there's any benefit to language design being removed from how it presents to people at the end of the day. Like you kind of want that contact with reality if you want to build tools for people, kind of.
I feel like that one of the joys of working in a visual language is that there's a lot of room to play with text. Like there's only so many ways you can use text to represent a programming language, but when you go into visual things, you can do some really weird stuff. One of the things that I think nobody gets right in programming in visual languages, and even Houdini, is that they all require you to manually position nodes, which is like the dumbest thing in the world. Because when you're trying to refactor stuff, you're like selecting nodes and like moving them out of the way. And
Is there an alternative?
they should all just auto layout. They should auto layout. We have like 20, 40 years of like auto layout research, that like GraphViz and all this stuff, and like there are actually really good auto node layout engines. The Y-Files is it's a proprietary one, but it's actually quite good. I use that for my custom programming language. So like there's no in my node based language, you cannot control the position of any single node, and that's like a strong tenet, I think, of any kind of good visual language, is that you shouldn't like. Because like that's in text, you don't have to think about where the text is. It's just on the next line. Like so, like I think there's a lot of like creativity that's kind of been missed in the sort of basic operations on a node based language. That I don't know. I think it's a very fruitful field to play around with, and it's kind of interesting.
I like that way of thinking. That sounds pretty promising to even me, who's not really a fan of visual languages. And a few minutes ago, you said something like if you want to use a value in two places, you split the tree and have the two lines go to the two different areas. What could eventually convince me that visual programming languages could be better is good use of 2D space like that. Because like that's the only difference, right, between text and visual languages when it comes down to it, is how they use the 2D space. And the ones that I've seen, they don't make very good use of the 2D space. They just end up being very spread out, and you can't fit as much on the screen.
Yeah.
But the benefits that you're talking about, like they make me wonder, like, is there some missed opportunities, some hidden potential in what we can do with that space?
Yeah, that's kind of how I feel. I think it's like, I think a good example is that like text, one of the constraints that text puts on code is that it reads top to bottom, and that's nice because you can always, like, if you have nothing else to do, you can sort of keep following the flow down, and sort of like there's a natural sort of pacing with that. And I think that more as a very baseline, I think most node languages should be top to bottom rather than left to right, for instance. But I mean, I think you can even like constrain node languages in other ways to make it more natural to write code that sort of reads that way rather than things that go in all directions. But yeah, that's kind of where I've gotten to too. Is it's like I don't feel like there is yet a visual language that is good. I think that if we could solve these issues, it possibly could be, but it's still kind of a long road. Like, and let me be clear, even auto layout is a hugely unsolved problem. Like it's like. If you constrain it just right, I think you can maybe make it work. But like writing a node-based auto layout system is like a serious project.
I also wanted to mention on the topic of using 2D space wisely. I think that's a really good point, and I think one thing that a lot of these like sort of node data flow languages do is they have the user explicitly encode relationships by like dragging a wire from one node to the other. And one thing that I actually did, I was writing a game that I have said I'm going to finish, and I will, but I was writing a game and it had like graph. It was basically like it's sort of a data flow, but it was like graph-based procedural crafting was the idea. Like I don't have to come up with recipes, I just have to come up with the ingredients, and then the combinatoric explosion of recipes just follows from that. And so that was the whole pitch of the crafting system. And what I did in that one was, instead of having like wires in this like quote unquote programming interface, it was all based on spatial locality. And so like connections you couldn't have spaghetti. Now that also disallows certain like.
Wait, can you elaborate more? Like, so it's based on like things connects to whatever's above them or something? Or?
Yeah. So it's basically like it's directional. So each node can have 4 children maximum, usually 3, but for the root node in this case it's 4 because it can have cardinal directions. 1 child in each cardinal direction. That was like a crafting. I'm not saying like that's what you do for programming, but that was for the crafting like setup. Right. And it had like a heuristic ultimately, which was you could just learn as a user pretty easily, which was like if a node is within this proximity and it's like within this part of the unit circle angle like deal thing, so this pie slice from the node, then it's like registered as that child within this distance or something like that. And then you don't have to like manually drag wires anymore and manually drag nodes. All you're doing is dragging nodes. Now, like you say, maybe you don't even want to drag nodes, and like there's lots of stuff to play around with. But I think that's one interesting way of like using 2D space in a different way and changing the primitives that the user is actually managing when they do this. And maybe to like make that concrete, one crafting would be like stick at the bottom, one child is a sword or like a sharpened blade, like piece of metal or something. Then it has two children that are like projectile nodes, or like they're like, I call them wing gems. They're like a gem shaped like a wing, and they like fire off whatever their children are. And then so you can have like water on one side, fire on the other, and then like you swing a sword and then you get all these effects shooting out. It was like, I don't know, it was fun. But that was the idea, and I think like not having the wires made it much simpler to deal with. But it also disallowed certain structures.
So yeah, I think to me the takeaway from that series of thoughts is that the data flow stuff that's like, especially in blueprints, and I haven't seen Houdini, but I get the impression that even in Houdini it is kind of like the boxes with wires going down the chain.
Could
right?
be better.
That is just an alternative to text, but the bigger question when thinking about non-textual programming is how should we use 2D space, and in particular how should we use it to express computation? Because like as a crafting system that sounds like a cool, like you make a roguelike out of that or whatever it's going to be, but I don't, someone has to figure out how you express a Turing complete system in that right. that can compile down to my x64. So if someday I want to write a kernel, guys, and I want to do it in a non-textual way, and
it
I
needs
don't know,
to be
like,
sufficiently dense.
Yeah. So anyways, I'll have one follow-up question. Evan's already kind of opened this door when he said that, like, to him, if he saw the non-textual like programming environment that made really smart use of 2D space, that would be the final like thing he needs to see to really flip his opinion on this. I'm wondering if for the other two of you, what is the opposite of that? What is the, like, this is a really cool, we were talking about rat holing earlier. How do the enthusiasts of non-textual programming, where's the brakes on this where it's like, you know what, I've spent 10 years and so have all these other researchers, maybe this is not going to work? How do you have an idea of how you would know if the excitement of that gut feeling that it should work is actually wrong? How would you find out that this is a dead end eventually?
I have an idea. I've thought about this a lot too, because I have several blog posts that are waiting to be written for this, but like part of the reason I've been working on this system is because I've like allowed myself 10 years. I was like, okay, you know what? This is not going to be like, it's not a fail fast project. I'm now, I think 4.5 into my 10 year. So I think it's going to be more like 30, but like, or whatever. Yeah, it is a good question. I think to me, the failure point would be like when you start picking apart at the 2D space problem and then you realize it ends up kind of just looking like text. I think there's a good chance, because I keep thinking of constraints. Like one of the constraints I was sort of loosely alluding to is that like, oh, maybe the node graph is, vertically aligned, or right, like it's constrained such that maybe it can't go too far. It's like it can only be so wide, so it has to look like a document in some kind of general sense. But you keep piling on those constraints towards like finding a good UX, and if you might end up looking something kind of like text, and then it's like, well, now it's just text with a bunch of lines between things, and is that really any better than where we started? And I think that would be a pretty strong failure point.
Mm-hmm. I think I get what you're saying there, but there's like a part of the allure of this is like there's like an infinity of untried ideas still, right? It's like, yeah, okay, so I tried this combination, I got too close to text, but that's fine. I'll just start from scratch. I'll take a different path through the.
You can try again, yeah. I mean, I think that there is some argument, because the thing is, I think you have to be honest. It's really tough to design in that space because you have to be able to be really honest with yourself about what works and why it works, because text does work really well for like lots of things. And so I think designing a good 2D interface also requires you to understand what is working about text so you don't lose it. But I think that, I mean, I don't think it's like a guarantee that they're like, it's necessarily better. Like I haven't personally seen any 2D spatial like visual programming that solves the sort of like spaghetti problem. And here's an argument for why visual scripting wouldn't work, which is that at the end of the day, with a text document, I can kind of read it from top to bottom, and I can get my bearings really easily. I can like sort of just skim code by like sort of like just kind of scanning it and getting a general sense of it. when you can go in multiple directions, like it's no longer vertically oriented, then suddenly there's no way to like amble or like wander through the document, which can be kind of problematic to comprehension because there's no directed flow. And I've seen this a lot with big like node-based languages. You just kind of get into this soup of nodes, and then it's just like, do I go up? Do I go down? Do I go left or right? Like, where am I? And like, I think that's a pretty big argument for 2D space. Like, maybe 1D space is just better because we are inherently like beings that like to consume things in an order. That might be some sort of critical thing that, you know, is going to be a stumbling block, but I'm also not totally convinced that's an issue yet.
I don't know if I would ever be convinced that there is no formulation to the idea that could work, although I could certainly be convinced that my current theories of it are wrong. And so, like, if I were to go through, like, with all of the non-textual experiments that I would ever want in the next, like, 10 to 20 years, and I find with every single one I try, everything turns out more complicated than it did in text, and it was, like, much harder to get the benefits I initially envisioned, and using it is not as good as I thought, and like there's all these problems, and it's clear that improving it is like insurmountable, then I think that would be a failure of at least that particular theory. And when it comes to like, is it worth working on, for me personally, it's like kind of depends on how old I am. Like at some point I'm going to be like, I just wanted to write that game that I've imagined when I was a kid. Like I'm done with this programming tech stuff. Like that might happen when I'm like 50 or 60 or something. Like, I don't know. But, and I think there's a real argument to that. The idea should be, if we have a new ecosystem, like one person should be able to write it. And I think it's similar to the idea of like, could we ever find the simplest formulation for a solution to this problem or something? And I think like the answer is clear. Like maybe like I'll make some mathematicians mad or something. Like maybe they're like, no, you can prove it in this particular instance or something. But like, I think as a general rule, programmers accept that like, no matter how simple you think your solution is, there's probably some other way to slice the whole problem up that it turns out to be simpler. And I don't know, maybe there's an end to that, but like not any that I can see. So
yeah, I think this isn't where I thought I would end the podcast, but I think this is what you just said ties into a really interesting mathematical idea, and I'm a huge fan of math. So there's this concept of Kolmogorov complexity, which basically says there is no halting. It's an undecidable problem to write an algorithm that determines whether or not a given expression of a computational idea is the shortest possible one. Now, that's not the same thing as what you're saying, which is it the most convenient possible one? But that's like a simpler criteria. I think like shortest possible is much easier to compute than like the shortness of something is easy to compute, and it should probably be somehow related to how convenient it is in some way. Maybe not directly. Maybe the most convenient ecosystem would have like 50% bloat over the shortest possible code golf thing. But ideally, right, like they would be related. And if it's undecidable, then it also means that there's no way to guarantee like that you've ruled out undecidability, and like the ability to write proofs for things are connected in interesting ways in mathematics, so that most likely a mathematician would agree like, yeah, there's no way for us to prove that this is minimal in the way that you're asking for. And therefore, even if you find an improvement over text, the journey will never be done. You could keep spinning your wheels and be like, but I think there are still gateways out there. But yeah, I think this is a really interesting and hard problem, which is we didn't even get to some of the other dimensions of this, like setting aside non-textual, we could explore the same question about languages, like what wins are there to get out of a new language versus just using C and improving the tooling, or what wins are there to get out of using the current tooling and the current language and just improving discipline. We've discussed these things, but there is sort of an undecidability to it, so that if you want to spin your wheels and run in the hamster wheel, there's probably always going to be a carrot there in the hypothetical infinite number of things we haven't tried yet. So deciding when that's worth it, and also other questions like which particular one to put your attention on, is always going to be hard and interesting, I think. So thanks so much to all of you guys. This has been a really interesting conversation. I hope you've thought so too. Yeah. Any last thoughts before we wrap it up?
I feel like, I don't know, there's like different like stages of programmer, like where you start by you just want to make some scripts, and then you want to make some libraries, and you want to make like a game engine, then you want to make a programming language, and like now we're at the level of like, no, I don't want to make a programming language. I want to make, I want to redefine what programming is entirely, and like, it's there's a natural inclination to keep stepping up that ladder, which is hard to fight, but is definitely super fun.
No, yeah, totally. I think what you said earlier about the non-tangible benefits is the real answer to like why bother. This is like, in a way, it's for my mental health, because I think there might be a better option than what I'm doing right now, and I want to try.
Keep that hope alive. Yeah.
Yes, exactly.
I think that people are naturally inclined to different problems, and so I've heard a lot of criticism of like independent game developers who go and rat hole on their own tools forever, and then everyone's like, oh, you never shipped a game kind of thing, and it's like, we need people working on tools, we need people not working on tools, we need people building games, we also need people not building games. Like, if everyone did the same thing, none of us would make any progress. Like, that's the principle of division of labor, and so I think, you know, wherever your mental heuristic takes you to, I think you should follow what you want to do most in your heart, as cheesy as that sounds. And I think that that's like an important takeaway for me, at least, because I like to work on rebuilding the everything problem, which maybe it'll be a waste of time, but like, I don't know, somebody's got to do it if we want things to get better. So
yeah.
If there's any place where listeners can find out more about you guys and follow stuff you're working on, where would that be? Why don't Evan, you go first?
Yeah, you can see most of my stuff at vertigon.dev. That's verdagon.dev. Yeah, I know, that's a lot. Yeah, I talk a lot about languages and software architecture there.
You can follow me on, probably easiest, just go to my website, johnaustin.io, John Austin.
So you can find all my stuff at rfleury.com these days, which is just my Substack. It's rfleury.com. I write blogs on whatever I'm thinking about, and including like some of the stuff we talked about here.
Great. Thanks, guys. It's been a great conversation.
Yeah, thank you.
Thanks
for having us.
Appreciate it.